We are going to continue to talk about some of the major issues that Kellett mostly brings up in the introduction, although I have my additional kind of thinking through consciousness, which also includes that module 13.2, and a tiny bit of another module in chapter 13 is that lateralization of the brain, but just so you're aware of where that's all coming from. So we started talking about defining consciousness, with our first possible definition being something we are aware of and can communicate with others. And this really comes from Neil Carlson's Physiology of Behavior textbook. This is his definition, and he provides this evidence of people with blind sight. They're clearly interacting with their visual world, but verbally they're denying being able to see it. Split brain patients, he really interpreted anything that's experienced by the right hemisphere as being below consciousness, because verbally they could not, our language is in the left hemisphere. The left hemisphere was not aware of that experience, and so verbally they could not communicate that with others. I threw in my disagreements on that one. And then spatial neglect. So people who have right parietal cortex damage, they tend to ignore. This is really about attention, that they're not paying attention to the left sides of either and or all of this, potentially depending on the damage, the left sides of objects, the left sides of space, the left side of their body. And someone brought up at the end, Cohen brought up at the end, that maybe this does not have to do with communication, because it seems to be more at that lower level, like awareness. And yes, I don't think that's a very good, it's great evidence for what they're not consciously aware of, but it's not necessarily evidence for that piece of it being important to be able to communicate with others. And I'm going to keep throwing some monkey wrenches into that, because I'm not sure I agree with that, being able to communicate with others. But again, I want you to decide what your definition is, what you think consciousness is. Okay, so I'm going to start by talking about brain activity, and we might define consciousness by we see a difference in brain activity. And again, I don't know how you feel about any of this, but there have been fMRI, so functional MRI studies, that have shown the possibility of consciousness in people who are in vegetative states. And so I don't know all my students yet, but someone, Christian, brought this up, I think, at the end of the last class. And yes, I'm going to go through some of this possibility of using brain activity to define consciousness in this way. So in an Owen et al. Study in 2006, they asked people who were in vegetative states to imagine playing tennis, and then they took an fMRI, and to imagine walking through their house, and they took an fMRI. And there was clearly a difference in the brain activity in the motor areas that were involved with imagining playing tennis, and then some of those navigation areas of the brain being involved in people imagining walking through their house. So suggests potentially some kind of consciousness, and in the very least that they heard and understood what they were supposed to imagine. And Monty et al. In 2010 used that exact, so imagine playing tennis if the answer is yes, imagine walking through your house if the answer is no. And they examined brain activity for people in vegetative states, answering specific questions, and they could answer yes or no questions by choosing whether or not they were going to imagine playing tennis or imagine walking through their house. And I apologize, I clicked on it before maybe I finished even thinking through what I want to think through. So to some extent, they are communicating, right? Because they are changing their brain activity in response to questions, knowing that that's what they are supposed to do. Anyway, so another completely different study looking at brain activity and making assumptions about consciousness. So there are experiments that use masking, and I have to go through this, what it means to use masking. So in the unmasked trials, they would see a blank screen, and this is happening through time, and then they'd see the word Grove, okay, for 29 milliseconds, and then they'd see another blank screen. And just so you know what happens when you see Grove for 29 milliseconds, in that 29 milliseconds, you don't really have time to see Grove, as we're gonna see in the next slides. But when I'm showing you these blank screens, what happens when I take away the word Grove and you see another blank screen after it? There is this visual persistence, okay, iconic memory, and that lasts about 250 milliseconds. So you have 250 milliseconds more to process that word Grove than in the next example. And this is using a pattern mask, so experiments using masking. In the second example down there, there's some pattern mask, okay, so these like random lines around the screen. And then they showed the word. And of course, these words are all, there are many words and they're all counterbalanced in both conditions. They might see the word salty, and they see that word salty for 29 milliseconds, which again is not enough time to take that information off the screen and process it. And then that word salty, that is replaced by another pattern mask. So we are, with the pattern mask, we are wiping out that iconic memory. You do not get that extra 250 milliseconds of processing time. Okay, in the non-masked condition with those white screens, those blank screens, people report seeing the word 90% of the time. So yes, they have time to process the word because of iconic memory. In the masking conditions, people usually report seeing no word at all. They're not only not processing the word salty, they don't see a word at all. In both the conscious and unconscious conditions, we see activation of the primary visual cortex, so that very first level of cortical processing of visual information, although the conscious condition activates that area more strongly. In the conscious condition, activity spreads to additional brain areas, including the prefrontal cortex and the parietal cortex. So do we want to, okay, define consciousness as not only being strong activity for visual stimuli anyway, for strong activity in the visual cortex, but also we want to see activity in the prefrontal and parietal cortex. People with damage to the prefrontal cortex, they need a visual stimulus to last longer before they become conscious of that visual stimulus. Also, when you see something and recognize it, so you're clearly conscious of it, it evokes brain activity that is precisely synchronized in several brain areas. Okay, and these synchronized action potentials, they are going to arrive simultaneously at their target cells, producing maximal summation. So it's not just about, we have both more or higher amount of activity in the brain, but we also see more efficient and better, more spread of activity. In addition, conscious perceptions of stimuli produce more consistent brain activity from one trial to another than when we say we didn't really consciously experience that. We see some brain activity, it's not quite as much, we don't see quite the spread, and it's not as consistent. So can we use this kind of brain activity as a measure of consciousness? Okay, and here's another one. So you can think about whether this is about brain activity about perception and maybe a little bit about both and the interaction that with conscious perception, okay, with perception, we're seeing a different kind of brain activity. The next few experiments I'm going to talk about use binocular rivalry. So what they do in this case is if you look at this on a screen and you put an index card so that the red vertical lines are presented to the left eye and the green horizontal lines are presented to your right eye, what's going to happen is you're going to, so you can't really see, so usually what happens is we have this visual world, it's all 6 centimeters apart because our eyes are about that far apart, and we've gotten used to taking in that information and integrating it, but we're not seeing two different stimuli overlaid from the two separate eyes onto each other, except in these wacky binocular rivalry experiments. So what's going to happen is you're only going to see one of those stimuli at a time. And each one, that's going to happen, each one for a number of seconds. For some people, it's like 1.5 seconds. For some people, it's 2 seconds. For some people, the right eye is stronger. For some people, red is stronger. It's going to vary. You're going to shift. Your perception is going to shift back and forth between seeing the red vertical and the green horizontal and the red vertical. So if you want to do that with an index card, it's a kind of neat experience. With those shifts in perception, which is our conscious experience, right? What we're actually seeing at that time, we see shifts in brain activity. And just so, I can't remember if I say this later on really clearly, one of the books I've read about consciousness comes from Jeffrey Alan Gray, and he talks about research with cats where they did this same binocular rivalry experiment on cats. And while we cannot ask them about their perception, we see the same kinds of shifts in brain activity. They're going back and forth between what they are perceiving. And we see that in their brain activity. Okay, some experiments using that kind of binocular rivalry and language. These are kind of fun. The fate of the unattended stimulus. So when you're saying, okay, I see the red vertical lines, and then a word fades on to the green horizontal lines, so the unattended stimulus, it captures your attention. And if that word is a word in your language, it captures your attention faster so that perception and the brain activity change more quickly than if that is a word from a language you do not understand. If that is a word that is important to you, like your name, that captures your attention even more quickly. So somehow your brain knew the meaningfulness of that word before it became a conscious experience. And I have a few concepts on a single slide here. So one, consciousness as a kind of threshold phenomenon that it reaches it below conscious awareness and then suddenly we're conscious of it, and there's a certain threshold for that. There's also a timing of consciousness, and one example is the phi phenomenon. So if we present a stimulus on the screen in one place and then it disappears, and we present a stimulus on the screen a few like inches over or whatever, if we have the timing right on that, you perceive a stimulus on the screen move to where the second stimulus is. And actually, that perception of movement occurs after the perception, right? Because that doesn't happen until you see the second stimulus. If all we showed was a first stimulus and we took it away, there'd be no perception of movement. It's when you see the second stimulus that you kind of go back in time and perceive that first stimulus as moving. I actually have an old link on here that does not work anymore, so I'm not going to try to provide it. The phonemic restoration effect. I keep looking for this again, and this is such a neat effect if we're looking at processing of speech and the importance of context. This comes from Richard Warren in 1972. But this phonemic restoration effect, where what happens is we fill in. So if there's a missing sound, we fill in that sound based on the sentence that surrounds it. And the original phonemic restoration effect was there's a sound missing from the state legislatures decided blah, blah, blah. And there's an S missing from the middle of legislatures. And it's really unambiguous. And people cannot tell where there's this broadband sound that replaces the S. They cannot tell where that broadband sound is. They cannot tell what sound is missing. They just hear legislatures, just like it had actually occurred when it didn't. But that phonemic restoration effect, that can occur for words that happened before the disambiguation. So I'm going to use a cough, which I think they sometimes used. There was a ent. Okay, it wouldn't be that abrupt. But there was a ent in the fender versus there was a ent in the forest. People would hear in the first one, they would hear there was a dent in the fender. They would hear a cough somewhere in there, but they wouldn't be able to quite place it. And in the second one, people would hear there was a tent in the forest. And again, people would hear the cough, but they wouldn't know where to place it. If you notice what happened here, there was a ent, that cough before the ent sound, that's ambiguous. There's no way to tell if that's going to be a tent, a dent, a rent, scent. You can't really scent, it's already disambiguated, but that can be a lot of sounds. And yet it's not until you get in the fender or in the forest, it's not until that disambiguation that, again, you go back in time and you fill in that phoneme that makes sense for that disambiguation. And consciousness comes later than we think. So I often have students who really think that most of their behavior is they're conscious of it. But if you think about our body language, our eye movements, unless we're becoming really meta-aware and noticing that specifically, for the most part, they are not in our conscious awareness. And that same book that I mentioned before, the Jeffrey Alan Gray, his book on consciousness, I think that's just the title, is Consciousness. One of the pieces of evidence he gives discussing consciousness is about tennis players. So when their opponent is moving towards the ball and moving their arm back in order to hit the ball in a certain way, before that information about how they're moving their arm to hit the ball, so that's going to give them information about trajectory and potentially, well, not even yet are they getting the force behind it, but even before they can get that trajectory information, the tennis player, before that information can go from the eyes to the visual cortex, that 250 milliseconds in that bit of processing, the tennis player is moving to where the ball is very likely to land. Okay, and I bring up basketball players as well because these professional people who are doing professional sports, so much of what they are doing has become automatic and under conscious awareness that if you asked them how they decided to throw the ball to a particular player in basketball or how they're making those decisions, they can't really answer that because it happened really very quickly and under their own conscious awareness. A piece of evidence that comes from your textbook that is under I think the decision-making part of this, that cognitive chapter, is that we are fairly unaware of when we are making a decision. So we claim to be conscious. We claim to be saying, this is when I made the decision. So we're conscious of making a decision seconds after a lateralized readiness potential suggests that our body was preparing to press a button. So these are people who are supposed to just decide and then press the left button or the right button. And that lateralized readiness potential, what we see of the activity in the brain, that is happening seconds before the person, when they're looking at a clock, is saying, this is when I became conscious of pressing the right button. So I really do want you to think about your own definition of consciousness. And I know I did throw you into the deep end of the water here. I want to give you these possible definitions and have you think about if you agree with the definition, think about the evidence, think about what evidence you would use to kind of define consciousness. So whether this is something we are aware of and can communicate with others, whether we want to define consciousness by brain activity, as many of these studies do. And some of those studies were really looking at brain activity in response to perception. And so how much do we want to take into account in our definition? Perception, attention, experience, and if you noticed at some point I said conscious perception. It starts to get into kind of a tautology, and if we're going to use the word awareness, it's a definite tautology where if you're defining consciousness with awareness, you're saying what's awareness? It's being conscious of something. So what is consciousness to you, and what evidence would you use to discuss that question? I'm going to come back to this on Monday, at the very beginning of Monday's class, even though I'm going to continue to move on in the major issues and in lecture on Wednesday and on Friday.